Okay, boys, we are looking at cone or conic sections today. So we'll start off by we'll look at what a conic section is. So a conic section is a portion of a cone which is cut by a cutting plane. So I'm going to illustrate the three main types of conic sections that we deal with. Now there are more. So first of all, we're going to draw a cone. Okay. Now, first one that we would be familiar with is the ellipse. Now the ellipse has an eccentricity of less than 1. Okay, now this is one that cuts both extreme generators. Okay, so that is an angle of less than 45 degrees generally, or basically. Now this angle here has to cut through both this extreme generator and this extreme generator to create an ellipse. Okay, so we'll write that down. That's an ellipse. Now, the second one we look at is the parabola. Now, the parabola is again a section of a cone. Now, the angle at which the cutting plane cuts at this time is parallel to one of the extreme generators. So in this case, it's parallel to the right extreme generator. So this line and this line are parallel. Okay. And finally, the last one over here is the hyperbola. Now, hyperbola actually comes in two shapes. There's actually two of them generally, because what we're trying to decide is that a cone has of infinite length but gets continuously wider. Now, this must be in between these angles. It either goes from 90 degrees to the plane. Okay, so it either goes between, so I'm going to put this on here. So it goes either between 90 degrees and this angle here. If it goes out as far as the extreme generator, then it becomes a parabola. If it goes more than 90 degrees, then it'll actually turn into an ellipse eventually, because what will happen is it'll be different to the extreme generator and it'll end up cutting across. Now, that is how they are defined. So the really true distinguishing factors. So this one here cuts both extreme generators. A parabola is parallel to either extreme generator. Now, hyperbola. Now, normally we only deal with ones which are 90 degrees to the central axis of the cone. So we normally only deal with ones that would be, so let's say, we would normally only deal with ones that are parallel to the central axis, okay? Now, in this case, that is not exactly true. A hyperbola actually can go from the parallel to the center of the axis, center axis of the cone, out as far as the angle of the extreme generator, and somewhere in between that angle. So if we say theta there, it can be anywhere in between them angles, but we normally only deal with ones which are at 90 degrees or parallel to the central axis, okay? So we generally deal with parallel to central axis. Okay, that's what a conic section is, and that's how they are defined.